Chapter 17, Section 1, Mechanical Waves. So what is a mechanical wave? It's defined as any disturbance that's in matter that carries energy from one place to another. So it does require matter to travel through. And when I say matter, that's your medium, so to speak. So when you have a source of energy that causes any vibration, that vibration is what's moving through that material. So just to clarify, medium, that's your material. It can be a solid, a liquid, or a gas. And there's different types of mechanical waves based on how they move through the material. So we have transverse waves, longitudinal waves, or surface waves. Transverse waves are the waves that vibrate at right angles to the direction of travel. So if it's moving forward, the transverse wave itself is going to be moving up and down. So at right angles to the direction of travel. So for instance, if you are shaking a rope, or if you are shaking a picnic blanket to get off all of the ants. So it kind of looks like this. Transverse waves also have what's called a crest and a trough. The crest is the highest point on the wave, and the trough is the lowest point, and you can see that here in the image. Longitudinal waves, however, have the vibration that's parallel to the direction of travel. So if you're moving forward, the vibration is also forward. So if you push or pull on a spring or a slinky, your motion is in the same direction as your push or your pull. So for example, as the picture you see here, it's kind of compressing and then stretching out in different areas. So the compression part you see, that's where it's all really closely together. And then we have the space where it's apart, and that's called rarefaction. So this is where you have the really spread out area. So compression's where it's together, rarefaction is where it's really spread apart. And then we have surface waves. That's the third type. And this is a wave that's going to travel along two different materials, so two media, and it's going to be right on the surface of those. So think about an ocean wave. It's at the top of the water, bordering on the air. So water is your liquid surface, or your liquid material. Air is a gas material. And like I said, ocean waves are your example. So it kind of moves in this circular pattern. And the thing about it is, if anyone that has ever been to the beach and seen one of the buoys out in the middle that kind of marks where your coastline is, the buoy itself, it doesn't come closer inland and it doesn't get further away out to sea because it's just moving up and down in that one spot. And that's it for today. We're only looking at the types of mechanical waves.